All right, everybody. Happy Monday. We got a couple things on tap today. I think everyone got the midterm in. I know one person had some unfortunate hardware issues where their laptop got wet. So I know of one person who has not turned in the midterm yet, because I think that's pretty fair. And if you're doing that badly on the test, you have to break your own laptop, then okay, you can have an extra day, but please don't break your hardware. Thanks for the sound check, Brian. Yeah, you should be able to see video, Snyder. Let me know if you have any trouble. So we're back from the midterm. I'll get those in. I think everything else has been scored for you. You guys did overwhelmingly very well on Hangman, which is great. Again, more of the focus on that was using functions, taking arguments for functions, using those variables, those values, those sorts of things. Right, not necessarily problem solving. It's a good way that we can look at how do you break a big problem down into smaller problems. So I gave you some specific methods that I asked for to make sure you didn't just go find the Hangman solution online, which is great. If you looked at one and it informed your solution, you cited your source, great. It's like, hey, how do I know if that's in the Word or not? It's okay. You guys figured it out pretty well. We did pretty good with that. So we've got our last individual project here. Tonight we'll talk about using lists, dictionaries, and tuples or tuples. I believe people still pronounce it either way. I think tuples is probably the more common way, but it's okay. And then we start hitting a couple special topics next week. So we're not going to go super deep into these, but I want to introduce what you can do with network programs, and web services are fantastic. That's a very common use for Python, is to go out and do something, right? We can go ask a web service for some data and do something with it. So I used to have a really cool stock market API we could use, but they put it behind a paywall, which I'm really sad about. But apparently Yahoo has one that's free, but it's slow. But for our purposes, I think that'll work. I got to go double check that and make sure that'll still work for us. We can do just a fun little example there with some web services. All sorts of cool things you can do online by getting data off the web, right, through these web services. They're fantastic. So we're not going to go super deep into them, just kind of highlight some of the things you can do. There's all sorts of amazing Python libraries out there. Again, most of our focus is not, here's a cool library, here's how you use the library. The focus is, here's some Python fundamentals. If you know Python, then you can go find cool libraries and use them. It's kind of that idea here. So we don't generally teach specific tooling, rather than here's like a broad base and you can go pick up the tools from there. Python objects, then we're going to do a deep dive on object-oriented programming in Python. Writing our own classes is super fun, and we'll use them as part of the final project, which if you do want to do individually, that's okay. There's no requirement we have to do this in a pair, but generally I find people either love it or hate it, but you'll get a better product out of paired programming. If you pair up with someone and work together, you can bounce your ideas off of each other, you can discuss things, you can help each other debug, you can even separate some of that work, figure out what goes on there. That does take time and effort, so you do about the same amount of work as an individual tackling the whole project as a pair teaming up to tackle the same project. So I like pairs, but again, I'm not going to make you do it. There's no specific requirement here for group work, but I think you'll probably enjoy it, and that's it's up to you. And then I'll hit a last couple topics. Python and databases is another huge piece that we need to look at, how we can interact with data in a database. Now, weirdly, well, I guess it's not even all that weird, but there's no prerequisite for knowing how databases work. You don't have to take a database course before taking this course. So if you don't have that foundation, it might not make as much sense, but it's okay. We'll get you through it. We'll figure out what Python does, how it works. You might not be able to do quite as much with it, but that's okay. We'll be all right here. And again, if that's the sort of thing you like or you are working with, you can dive a little deeper there. And then the last week of new content will be visualization and plotting from chapter 16, where we'll look at, okay, once I have a bunch of data, what do I do with it, right? Because generally just looking at numbers is really tedious and tiring and difficult for people if you just look at a bunch of numbers. But if you can visualize it or plot it, graph it, it works a whole lot better for people. And this is a lot of fun here. And really one of the big things we do with analyzing data is figuring out ways we can visualize it here, so we can kind of tell a story. It is really important when you're working with data, is to not just, hey, here's some numbers, but kind of tell a story with your data. It is really powerful. That's cool purpose. You use Python in Destiny 2. I didn't know you have tools that you have to build for games. That's kind of fun. And then our last week of class here on August 22nd, it'll be my chance to sit in your seats, and we'll take turns presenting. So each individual or group or partner, pair, can present their final project, and we'll just have a chance to look at how everyone kind of tackled it a little bit differently. We'll show you results and talk about your code a little bit, and it should be a lot of fun. It's like 5 to 10 minutes tops. If you start going longer than 10 minutes, I'm going to tell you to go sit down because you're just taking up too much time here. But aiming about a 5-minute, it's not even really a presentation. You don't need a PowerPoint or anything. We're just going to run your code, show us that it does what it's supposed to do, and then kind of talk through, hey, here's what we did. Here's what was hard. Here's what, some of the steps I took, that sort of thing. And usually that's a lot of fun. So if you are remote, you're welcome to join on Zoom, but you do need to present. I won't score it if you don't present it. So that's sort of the idea here. And as far as we knew when we signed up for the course, this was an in-person class. So there's no real excuse saying, "Oh, I'm busy that night," because you knew we had class that night. So that being said, if you're out of town because you can't avoid travel or whatever, if we absolutely have to, I can find another time for you to present to me. But I'd really rather not. It's much more fun if everyone gets to see everyone's final project. So that's what's coming up for the rest of the semester. So we have our files lab. If anyone wanted to talk about that, we could talk about the files lab, finishing out that item management tool we wrote. Right, so we did like the first half, and then I said, okay, now we'll go in and add the second half here. So we were able to have the file with the quantity and the price, and then go buy items. And now we wanted to add the manage items, so I can go add items or remove items or update the price or the quantity of items, kind of on a management side here. And again, that's not how you would really do a point of sale system, but it's sort of a fun, easy example for working with lots of files. That's pretty easy to conceptualize. If you're doing a point of sale system, you would use a database, right, where you have the one source of your information, and then all of your registers will connect to it, that sort of thing. But it's fun, and it's a good, nice way to use files here. So happy to talk about that if anyone is interested. If not, we can get into lists, dictionaries, and tuples. I know it looks like 3 chapters, and it technically is 3 different chapters, but lists and tuples are very, 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 very similar. And then dictionaries are similar-ish, but do some extra really cool things. And then we'll talk about the last individual project as well. That sound okay? All right, so should we do the files lab, or should we just jump right into new stuff? I'm open to whatever. Heard 1 vote for lab. All right, so let me fire up PyCharm here. Start. There we go. Come on. And I'm just going to grab the. That's midterm review. I don't need that one. The files project we did, right? Oh, it's probably my recent, right? Recent. Yeah, it'll be from week 7, I think. Yeah, so this was the current piece here. So I wanted to start with this, right? Where we're going to, okay, as long as you're going to keep on buying things. So we need that loop here, and figure out what we're going to buy afterwards. So what did this all do? So we can buy items, can update the file, continue buying. Okay, so that was this continue buying loop. So excuse me, grab that piece, and we start up a new project here. So this is lab. What was the number for that one? Go look. Lab 6. All right, thanks. So this is lab 6. So we've got shop mode and manage mode. So shop mode was done, right? Copy paste it from the class repo, easy here. So this will be something like if mode equals shop, right? We'll go into shop mode, essentially. Input, do you want to shop or manage? And then maybe take that to lower, just so that we can compare lowercase to lowercase, make life a little easier here. And then it's always a good habit here to cite your source. Let me go get our course repo. And this was from week 7, APY. We can say shop mode from here. nope, pound sign, there we go, shop mode from, there we go, here's our citation. So if mode's not shop mode, then, right, else if, elif mode equals manage will be a manage mode, right? So shopping's fine. We can buy things. We don't have any files currently, so we probably can't buy the thing. Oh, and then we got to add some imports here. So we want to import OS. Path is file, right? If there is a file there, great. We'll go ahead and try it. We'll have a breakpoint there. That's weird. And then we can update the file, making sure we had enough, right? And we're going to keep on going. Right, so for manage mode, then we need to add a couple of pieces here. For manage mode, we wanted to be able to create an item, update an item, or delete an item. Right? So for creating an item, if the file already exists, well, we're not making a new item. We should say, well, you can't create that. You already have one. You could automatically turn it into update if you want, or you can make update be separate, kick it back out to that menu. Either way is perfectly fine. So we need to ask them, are we adding an item? Are we updating an item or removing an item? So we'll get the, I don't know, from here, choice is the input of you want to add an item, update an item, or remove an item. And again, probably lowercase it here to make life easy. And then we can say, okay, we'll check if it's add. So if choice is add, here, we'll do something here in a second. And then else if my choice is update, again, we'll come back to that. And then else if my choice is remove, we'll do something. Otherwise, we can print don't know, or I can't help with that. Can't help with that. Right? And then again, this could be some sort of loop. Do you want to keep managing items or however you want to do that here? So sure, why not? Continue managing. Do you want to manage more? Yes or no? We'll stick that on at the end here. And all of this can be in a, so continue managing can be a Y here. And while continue managing is equal to a Y. We'll keep on going here. Is that tabbed in funny? I think it is. Yep, it is tabbed in funny. So start at Y so the loop runs, and then ask them, okay, what do you want to do? And then we can start adding in these ones here. Again, if we wanted to, we could turn these into their own functions. Right? They don't have to be, but it's a nice way of kind of breaking this up here if we wanted. Right here, what is the add item function? What is the update item function? What is the remove item function? We could do it like that if we wanted here. So we could call add item. Sure. Or we could call update item. Update item. It's really wide here. I'm sorry. Bring that back down. Update item. Or we could call remove item. Sure. We can do something like that if we wanted. And really, they probably all need the same name here. So we could just have a method or a function for ask for the item name, or we could ask for the item name once and give it to all of them here. Well, why not? We'll say item name is an input of is the item name you want to manage here. And then I can maybe pass the item name to each of those. Sure. So we can go define some of these functions here. So define add item, give it an item name. Well, to add an item, we're going to create the file, right? Get these values here and write them back out, right? So this is open for write mode, and then write the file, and then close the file. So we have the item name, right? Is going to be the name of our file. If you wanted to throw a txt in there, you could, right? Item name plus .txt. We could throw that in. Sure. Or maybe a formatted string might even be nicer here. Put that as a item name .txt. Right? That makes like a nice pretty string. So that's the name of the item. We'll add in the txt. Add it in write mode. So before we do that then, right, if the item exists, we can't go do this. We don't want to go do that thing. So we need to check to make sure that file doesn't exist. And I think we had to go back and look at this one, right? So we looked at exists. Did we look at exists? Did we not? I thought we looked at if a file was there or not. Now I'm going crazy. Yeah, I think. Is file? Is it just is file? Python file exists. Let's go Google it again here. How to check if a Python file exists. Oh, it's from OS path. Do we not do that? Yeah, I thought we did. Path. Yeah, we have path. Join. Huh. Maybe did I not commit it? I think it might have been exists. Doesn't have it. Okay. I don't know. That's interesting. Oh, is file. That's what we looked. Yeah, so we did is file was the second option here, rather than a path exists. So that's the approach we took, right? If it's a file, then it exists. So we can check if it does exist then, right? So maybe the item file name then would equal this. We don't have to do this twice. And if not, os.path.exists, given the item file name. If it does not exist, then we can go write the file, right, with the item file name. Now we need to know what the price and the quantity are, so we should go ask them for the price and quantity, right? So price is input of, please enter the item price. And then if we know it should be numeric, we probably want to make sure it's a numeric thing that we write. Because if I say enter the price and they like type in the word 10, later on it's going to really upset my program. So I might as well just convert it to float here, just so I have a floating point value, right? And then how about just quantity? It's probably easy here. And then again, I think we said for quantity, it probably makes sense to be an integer value because you probably have a whole number into the quantity of items of the item, something. Right, we'll write the file and we'll close it. So if it does exist, then, right, we'll just tell them print file already. I don't know, that item is already for sale. Please update it first, or instead, update it instead. Right, and that could be our add item function. There's nothing wrong with doing that inside of our if block here, but again, it's just kind of breaking it up, doing some of that functional decomposition. Because we're fans of trying to make a big problem into smaller problems, and it's easier to solve smaller problems. All right, so we'll do for update item then. Define update item, give it an item name. Now it's almost identical to this here, right? Except we kind of want to do it backwards, right? We want to make sure if it does exist, right? Well, we should tell them, right? Display the current price and quantity. So we need to go get the current values and ask them for what the new ones are. And we'll overwrite the file with those new values. So if it does exist, then we can go open it and read it, right? So do this, right? So if it does exist, then we'll open the item file name, we'll get the price, we'll get the quantity, we'll close the file, we'll tell them here's what it currently is, and then we'll ask them for the new item price and the new quantity of the item, and then we'll write those items to our file, right? So if it does exist, great, and then if it doesn't exist, that item is not for sale currently, please add it. Right, so similar process here, just ever so slightly different. And then removing here for a remove item, given an item name. And we need the name of the file here. And then if it exists, great. If it exists, it's os.remove the item file name. Otherwise, print that item doesn't exist. Like that was it, right? If you're trying to remove something for sale, sure, it's done. You don't need to try again because that item doesn't exist. And I think that's it. So this part is real similar to the other part. So we could probably further turn some of these things into functions. right? If we wanted to go that route of having not repeated code, because if you have repeated code, the general rule of thumb is you should feel bad about yourself, right? It's not the worst thing in the world, but a little bit of feeling bad about yourself is normal. So we could then say, oh, well, if I'm doing the same thing, I'm going to open a file and get some values back out, we could turn that into a function. Sure, why not? Let's go look for that. So we can do that. So how about we make a function here for get item file, or get item price and quantity given the item name. And I just saw, so I used to always think English is hard, but that Twitter was really silly and not very good for like social media. And I still maintain it's not the best platform to like keeping in touch with friends. But in terms of like being able to share knowledge with people and having popular people in tech share cool things has been super fun. So I've got a bunch of tech people on Twitter now, and I keep learning new tips and tricks and things all the time. But I saw Visual Studio, which is Microsoft's integrated development environment, is just now shipping a inline spell checker. And I'm like, I've been doing this for how long now with my other tools? Like, you just now get spell checking, but better late than never, I suppose, because spell checking like in line as I'm typing stuff has been so nice, because I'm terrible at spelling things, and it doesn't really matter if you can't spell. It's okay. Tool will fix it for us. Yeah, with C#. C# is fantastic. It is one of my favorite languages for sure. I'm super excited. I got to teach the course again over at Dearborn. So that was like my favorite class I got to teach, because it was just a language elective where we got to do a bunch of fun stuff in C#. So I was like, here's all the cool things you can do. And it was a fun 15 weeks. And we built a game that ran on Xbox and stuff. And it was fun. Anyway, I think I've had a lot of coffee today. I did not get my coffee pot fixed because I would have to pay to ship it out to Black & Decker for them to send me a new one. It's like, this is stupid. So we got one on Prime Day, and I have a new coffee pot, and I've been using it. It makes me very happy. All right, it's not too late, Professor Burp. I'm sorry? Exactly. I mean, I think caffeine content in coffee versus Coke. So coffee, I think this varies a lot depending on which grounds you use too. But that's 95 milligrams of caffeine per. Doesn't this tell you how much caffeine is in it? 34 milligrams per 12 ounces. So that's almost triple, right? If I do that math right, if Coke is 34 milligrams and coffee is 95, and I'm not sure this is by 12 ounce. This is important here. Which is healthier, coffee or Coke? Obviously coffee, right? Coke. Yeah, look at that. See, the internet agrees with me. Life is good. Which one has more caffeine? Okay, 12-ounce cup of coffee, 12-ounce can of Coke. This is why, friends. This is why. So anyway, get the item price and quantity. So given the item name, so again, if it exists, great, we'll go do this thing here, make sure we close it, and then we can return price and quantity. And again, item file name, sure, we can copy that off if we want here. Why not? Awesome. So now I have the price and quantity. We'll just call it quantity. How about that? Price and quantity. So to use those then, right, if you can return more than one thing, I think we mentioned this when we talked about functions way back. Some people picked it up right away, other people didn't. You can just assign those two things to two variables here. So if the file exists, great. Probably otherwise. So with a function where we're returning something, if we don't return something, by default, we're getting this return none. Right? If you don't return a value, the function gives you back none implicitly. So this here is redundant at this point because it would happen if the file didn't exist. Either way. So, we could put it here if you want to see that it's explicitly happening, but it's going to happen automatically for us. Or you could return different values if you wanted, depending on what you want to have it do. So not too big of a deal. So if we're going to update an item, then I'll have price and quantity. So If the file exists, go do the thing. I guess we still need that. Just double checking if the file exists or not. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over the University of Michigan Dearborn College of Engineering and Computer Science. I think that's the fastest I've ever said that. I'm a little wired, folks. I apologize. Just shout at me, and I'm happy to slow back down. All right, so price and quantity. We can say price and quantity equal my get price and quantity from the item name. Right? We can even, let's even pass that in. Why not? Item file name. How about that? We'll just pass in the item file name here, and then it's done. So I can get those out here. It's automatically going to get closed, and then I can print my price and quantity. And then writing the file, again, we're doing this more than one time here, right? So how about I'm just going to move these prompts over here, and then I'm going to take this writing the file here, and we're going to turn this into a different function here. So we'll have a define write item file, given the item file name, the price, and the quantity. Quantity. Right? That's all it needs to do. It doesn't need any other returns. It's just going to do something here. Right? So I can write my item file. Write item file, given the item file name, price, and the quantity. Okay? So same idea here. When I'm going to create the file, it's doing the same thing. It's going to, again, we need to ask for price and quantity, and then we'll go write the file. So we can write item file, given the item file name, the price, and the quantity. Why is my tabbing so off? I don't know what's going on with this. That's super weird. Okay, so now these are a little simpler here because I have my essentially read and writes done separately. So one method will read the file and one method will write the file. So to add the file, I just make sure it doesn't exist. Otherwise, I can give them the error. I'll get the inputs here and I'll write the file. To update, make sure it exists. Get the existing ones by reading it, tell you what it is, get the new values, and then write it. Removing, again, doesn't change. And then for shop mode, we could also change that as well because we're writing that same file here. Right? So it's going to be the item here. So it's item file. Sure, so this will be the write item file, right, given the item. Right, now, we probably want to add the txt here because we're not doing that everywhere else. So I'm going to add that in as a formatted string, item.txt, just to keep it consistent, given the price and given, now we can do the arithmetic right here if we want, right? Force some arithmetic to happen. Oh my goodness, that's the wrong one. Where's my shift key? Thank you. Right, and then we don't need to repeat this line of code either. So here's the writing. Right? For reading, we can do the same thing. Okay, we'll get our price and quantity. So price and comma price and quantity available. Okay, I called it quantity available. That's fine. So they get item price and quantity given the item. Oh goodness. Let's change all that because I don't have to do this more than once. So we'll do again the item file name, I guess. Item file name equals this one. Just make that a little cleaner here. Oh my goodness, what do I do with my mouse? Nope. I've got these buttons on it's like a gamer mouse because I've been using this style of mouse for years and years and years, and it's got buttons to increase your sensitivity, which is super handy for games. All right, so item, add the txt in here, item file name, and then here's the item, cost, price, quantity available, great, quantity to buy, great, as long as it's greater than that, how many do you want to buy? Sure, it will cost you this much, and we'll update the file. Okay, so we've taken as much of the repeated code out as possible, I think. Right? Every time we're writing the file, we use the write method. Every time we're reading the file, we use the read method. The other ones just kind of ask for input. So if we wanted, we could combine these inputs as well. I mean, they have separate prompts. So might not be the most useful thing at this point, because like, hey, what's the new price versus what is the price? I don't know. I don't know if we're actually saving a whole lot there. So I'm pretty happy with it at this point. We should actually try it though, right? Make sure it works. So let's give it a run. So we need to manage first. Okay. We need to add an item. Well, let me update an item first. And tacos. We don't have it for sale. Do you want to manage more? Yes. Okay. Let's add an item. Let's add a taco. How much does a taco cost? $1.99, and we'll have a dozen tacos. And sure, let's manage some more. Let's add some nachos. And oops, that's the wrong one. Can't help with nachos. All right, manage more. Not to add an item. We'll add nachos. Nachos are probably $2.99 because we're adding in the cheese here. And we probably only have like 6 of these in stock that we don't need to manage anymore. And our program ended. So we should have nachos, $2.99 with 6, and we have tacos, $1.99 with 12. Our files got created successfully. Looking good so far. Now, we should feel pretty good shop mode works because we copy pasted it from last week. So we should make sure we can go delete an item now then, right, and update an item. So let's manage, and let's update an item. Let's update our taco. Uh-oh. The name item's not defined. Oh, dear. Item costs. Oh, it is update item name here. Item name. There we go. That was my bad. Let's try that again. This is why we try it, right? So manage and update and taco. All right, quantity available is not. So we just called it quantity. Quantity. Okay. Right. One more time. Manage taco. Nope. Taco. Let's manage more. You want to update an item. You want to update a taco. All right. Taco costs $1.99. There's 12 of them available. What's the new item price? Well, let's decrease our prices here. $1.75, and let's say we've sold half of them here. Don't want to manage anymore. So now taco should be updated, $1.75, and there's 6 of them. Great. We have 6 left. We need to sell them by the end of today, or the health department says we can't sell them anymore. Let's put them on sale. Right. There's a gas station just down the street from me that has like a little. They've got breakfast sandwiches, either on biscuits or on bagels or English muffins. And if you go in at lunchtime, they're all for sale. Which they've been sitting for a while. They're a little dry, but they're like half off, and they're still pretty tasty. All right, so I think our lab works. Questions, thoughts, concerns? Feel all right? Let me commit this to GitHub here before I forget. This is for 2131. Here's lab 6. All right, awesome. Does McDonald's Coke have more caffeine, perp? All right, I have to search this now. Caffeine content in Coke at McDonald's. It's in a large Coke. Okay, I don't know if it's any different. So I did hear one time what Coca-Cola gives to McDonald's is different than what they'll give to other people for fountain machines, and something about the packaging that it's in is supposed to make it better at McDonald's. I don't know if that's true or not, but someone told me that one time. So I don't know. God bless everyone who works in food service. That is not a job I wish to have. And my daughter, she's 13 now. She's like, hey, when I turn 14, McDonald's will hire me. Like, really? You want to do that? She's like, yeah, I want to go to work and make money. Like, but really? We have a friend of hers got a job at 14 and started working and got yelled at in the drive-thru by someone for giving them the wrong order. Like, who yells at a 14-year-old kid? Or anybody in fast food. Like, you don't need to yell at the person for giving the wrong order. It just makes me sad. Like, we're just we're unhappy people. A big metal vat of Coke. Okay, yeah, that's right. So it's delivered in metal instead of the plastic bags or something. I don't know. All right, new stuff. So this is officially week 8, right? Now that I'm coming back to this, I'm realizing naming them week by week without additional information makes it hard to find things, and I'm feeling a little bad. Like if it was week 8, lists and tuples and dictionaries might be better, because then you can go back and see what it was and what week it was. But I don't know. Maybe we could change the name of it here. But it's probably okay. So the idea with a list or a tuple. And we'll start with those ones first. We'll come back to dictionaries. It's a collection of things. So we can finally we can store more than one item at a time. Now we've already done this when we talked about strings, right? A string, I said, is a collection of characters. Right? We can loop through it. We can look at one character at a time. We can do stuff with each character. So a list is similar to that, but it's more flexible. You can store anything you want in it. Now, Python is fun in that it uses different braces for different items here. So my list is square braces here. My tuple is parentheses, and my dictionary is curly braces. That's just what it is. And it's okay if you have to go look it up. Until you've been doing it a lot, that's fine. Just go look up what you need to use here. It's not really worth memorizing. And the big difference here is lists are mutable, which means they can be changed. You can add things, you can take things out. Here, tuples are immutable. Once you've made a tuple, immutable, spelling, immutable, 2 M's, immutable. Once you've added something, you can't take it out. So really an empty tuple is dumb. It's not useful here because you can't add anything to it. It's stuck forever. But like if I have 1, 2, and 3. And you just comma separate your items here, 1, 2, and 3. And really, you can do it with the dictionary too. It's just a little funny. Here, dictionaries are mutable as well, but dictionaries are a little bit different here. We'll get to them next. But we'll do lists and tuples first. And you can use that for loop just like you could with the string. You can say for item in my list, we can print item. Now you can iterate over real quick. And for item in my tuple, we can print the item. 1, 2, and 3, and 1, 2, and 3. Right, how about we items in my list and items in my tuple. Right, you could loop through, get one at a time if you wanted. You can actually just print them all out too. You can print my list, and you can print my tuple. And Python says, sure, we can do that. Lists get the square braces, tuples get the parentheses, right? Which is how we created them. Fantastic. They work really well. The other thing we can do, remember when we looked at strings, we said each item has an index. And we started at 0 because most programming languages start at 0 for lots of reasons. I think we talked about the calculations, maybe. It's the memory address of where the start of it is. So you can get at individual items one at a time. So we could say for index in range length of my list here, we can print the formatted string of index, the index, and the value is my list square brace index. Right? Just like you can get at an individual character, right? We can get an individual item out here. We can get one item at a time. And you can do the same thing with my tuple and my tuple. We can get the index and my tuple at that value, at that index. So at index 0, there's a 1, index 1, there's a 2, index 2, there's a 3. Same with both. Now, lists, because they're mutable, we can change those values. So I can say, hey, let's say I want to take my list at index of 1, and I'm going to change the value to 42. Right? Perfectly fine. If I try and do that with a tuple, it's going to fail. And we get a nice message. Tuple does not support item assignment. You can't change the values of tuples. Right? Fails. Tuples can't be changed. Right? So that one's no good. We'll just ignore that one here. But then if I wanted, I could print my list again. And we'll see there's a 42 now at index 1. So you can change values in lists. Okay. What you don't want to do is add and remove items as you're looping through it. Weird stuff will happen here. So let me make these a little longer here. So we'll do 3, 4, and 5. And then we'll do that to the tuple, 4 and 5. And sure, why not to the dictionary, 4 and 5 here. So we'll get all those values out here. We'll get 1 through 5s. Right? And now I have a 42, sure. So if I wanted to, and again, this is just a silly example here. This will be remove all evens. I'll say for value in my list here, if value mod 2 is 0, that is even here, I'm going to take my list, remove the value, and then we'll print the list. Right? Should remove all the evens, so it should remove a 42 and the 4. Okay, that one worked for us. I think we got a little bit lucky here. Let me go back and make this one a 6 here. Let me run it again. It didn't remove 6 this time. Left the 6. You don't want to modify lists. Don't add, remove from lists while iterating. So what's happening here is this for loop is actually remembering what item is where, and then when you remove something, everything has to shift down a space. So we had, right, in our, let me print it again real quick. Print. Oh, it was right here. So we had 1, and we iterate over 1. 1's not even, right? No problem here. 42 is even, so we're going to try and remove it here. When 42 gets removed, 3, 4, and 6 get bumped down into that place here. So now we just have 4 items. So when it goes to the next item, it's actually skipping over 3 and going right to the 4. So if we just print the value here, it'll say currently checking value here, and that one. So it only checks the 1, the 42, and the 4. Because when it removes something, everything else shifts back down. Because you can't leave a gap here. You can't leave a hole. The list needs to have something there, which is nice because leaving a gap there could cause other problems. So we just need to know the behavior of this. So what you want to do then instead is you can iterate over a copy of the list here. So this doesn't work. Where was our note? Don't, yeah. Did I say don't iterate? Am I losing? Right here, don't add or remove when iterating. I put that in the wrong spot here. Okay, so instead what you want to do is you want to go over a copy. To make a copy of a list, you could take a slice of it. Remember the slice notation with strings? You say, hey, start it here, end it here. And by the way, they're both optional. So if I just put a colon in here, this will take a slice of everything in the list. So it means it's a copy. I now have a copy of the list here because I've sliced the original. So when I iterate over a copy of it here, and I remove something from the original, my copy doesn't have it removed. So I'm going to look at every single value because they're not getting removed from my copy here. So this one will work because it'll check the 1, the 42, the 3, the 4, and the 6. Because we're going over the copy. We took those numbers, we stored them over here, and we're going to say, okay, give me the first one, give me the second one, give me the third one, give me the fourth one. I've got that copy of them. Then I can remove from the original. But if you iterate over the original, as you remove things, they disappear, and things get shifted underneath us. And it's bad luck. Right? Bad news bears. So I should make this one and say it doesn't work here. This version doesn't work. Right? So this way doesn't work, but going over a slice does work. So you can use that same slice notation. You can say, what's the start index? What's the end index? Right? Well, you can take every other if you want to use that stride notation as well. So you've got the same options we can do with strings, we can do with lists, because it turns out they're both collections. Right? And you can take slices of tuples as well. You just can't remove things from tuples. The other fun thing you can do with lists is you can add items to them at a given location. So there's an append will add something to the end of a list, right? Adds to the end. We could add in, I don't know, 50 or something. Sure. We can print my list. So we added in 50, right? It gets added to the end. If you want to add to a specific location, we can use my list insert. And insert says, okay, what index? Well, I want it to become index 1, and then what value? Well, let's add in a 100. So insert at what index, what value? Right. So I'm going to put 100, so it is the new index 1. So now I should have 1, 100, 3, and 50. So I added it in, so it's index 1. Right? This is index 0, this is index 1, this is index 2, this is index 3. And lists are flexible. You can keep on appending forever. So if you've come from a language like Java and working with arrays that are fixed in size, Python lists are not fixed. You can add and you can subtract from them anytime you want here. Now remove, notice, took a particular value. If you wanted to remove something at a particular index, my list, let's say you use pop to say what index do you want, and it defaults to the end here, removing the last item. So if I don't give it an index, it's going to remove the last item, will remove the 50. If I give it an index, say, hey, I want to remove, say, the 0th item, it'll remove the 1. And all I'll have left is 100, 3, and 50. So we got some cool notations for these. Sorry, my insulin's beeping at me here. What's the problem? High sugar. Okay. High is better than low. All right. So lists are a lot of fun. You can do all sorts of cool things with them here. Take a look real quick. Lists. Nope, that's files. Here's lists. The other crazy things you can do with lists is Python doesn't care what you put in it. So I can make a crazy list. Here's some string. Here's a floating point value. Here's an integer. And here is another list inside of it here. 2, 4, 6, 8. Do we appreciate? And Python doesn't care. So lists don't check the type. So in other languages, if you've dealt with arrays, you know you can only have a single type of item in there. It's all numbers, or it's all strings, or it's all a particular kind of object. Python doesn't let you put anything you want in there. Right, so then if I were to print my crazy list, it'll print out. It doesn't care. Right, we get a string, we get our floating point number, we get our integer, we get another list inside of the list. Now, it can be really useful, though, to have a list inside of a list, a two-dimensional list, right? A list of lists. So I might say, hey, here's my board, then, is going to be a space, and a space, and then, that needs to be inside of another list here. So that's the first one. I'll add a second row and a third row here. Let me tab those ones in. So this is my tic-tac-toe board, right? 3 by 3. It's a list of lists. So if I wanted to place a character somewhere, the first index is going to be what row it is, right? Because that's what item is it in the main list. Well, each row is an item. So this is index 0, or row 0, right? Row index 0. This is row index 1, and this is row index 2, right? The first item is at index 0 is a list. So if I want to get at a given location there, if I want to say, hey, board at index of 0 is the first row, and then at index of 1 will be the middle item here, right? Because this is index 0, this is index 1, this is index 2 of the list that is at board index of 0, right? So we can mark an X. And then we can print the board. Now, the problem with printing the board here is it's not going to be very pretty because it's not going to put the new lines in at all. So what we really want to do, we want to say for row in board, we want to print the row. And that will give us the new lines in between each one. Right? And now I have a nicely formatted board here. All right, so if X goes in the middle there, where should O go next then? So X win here, where should O go if they want to win at tic-tac-toe? Or at least not lose at tic-tac-toe? Yeah, in the center. Okay, so the center is going to be row index 1, column index 1. So let's make 1, 1, oops, 1, 1 be the O. Okay, now we have an X and an O. That should be a lowercase o maybe? I don't know. That was a lowercase x, I guess. Right, and you can keep on going here, picking these locations, putting them in over and over and over. So a list of lists is real powerful, and a lot of times you'll see that. If you want to get crazy here, a three-dimensional list is a list of lists of lists. And this is when it starts to hurt my head, because I really, at this point, can't keep track of it anymore. So here's, I don't know, we'll just put in some spaces here. Why not? Right, so that's one dimension. So that's the first layer here. So if we were building a Rubik's Cube, maybe, right? You've got the bottom 9, then you have the middle 9 and the top 9. Oh, actually, there's not the ninth one in the very center. There's technically 8 in the middle row. But that's okay. We can rinse and repeat here. So we'll have 3 layers here of our 3-dimensional list. You can go to 4 dimensions or 5 dimensions or 6 dimensions. Python doesn't really care, but beyond, I mean, even 3 dimensions is pretty crazy to have a list of lists, because it's really hard to keep track of what you're doing at that point here. So beyond that, definitely don't recommend it at all, even though you're allowed to. But sure. So I guess this middle one wouldn't exist then if this was a Rubik's Cube, right? We could assign different colors of these values here, and then you could solve your Rubik's Cube and do that sort of thing. But you can put any kind of item that you want inside. So there's no guarantee that it is an integer or it is a string or it is what it happens to be here. And then you can pass lists to other functions. We could define a function, not the word function. How about this will be get the sum, no, not even the sum, average value in list here, given some list. Right, so we need the total, then starts off at 0, and then for value in some list, we'll take my total plus equals the value, and then when we're done, we can return the total divided by the length of some list. Remember, length will tell you how many characters are in a string. Length will tell you how many items are in a list. Now, if you try and take the length of a 2-dimensional list, it'll just tell you how many rows are in it. Right? Because as far as it cares, in this board here, the board itself has 3 items. This is 1 item, this is a 2nd item, this is a 3rd item. Right? Because a list is one thing, technically, which is, sure, it's kind of fun that way. So if I wanted to then make a list here of values, or I would take, print the average values of my list. Well, this is the average of my list. And add in some curly braces, make that a formatted string. We can print my list again just to see what's in it. Get the average out. Print. Oh, I didn't end the quote here. That's why I didn't know what it was doing here. There. So the average of 150 and 3 is 51. Sounds about right, right? 153 divided by 3 is 51. I think that's correct. So you can pass a list as an argument to a function. And this is really common, right? We want to collect a bunch of items here. I don't care how many items are in the list, right? It doesn't matter. I'm just going to loop through every value in it, sum it up, and give you back the total. Now, if I give you a list like my crazy list here, my crazy list, is this going to work? No. It's going to say you can't take an integer and add a string, right? When you're looping through, when you take value in some list and you try and add them together, ints and strings, they don't stick. Right? We can't add. So you got to be a little careful. But, it works generally if you do the right things with it here, which is nice. So lists, they're mutable. We can change them. You can traverse the list. You can go by index here. The for loop is great. List operations. You can add lists together. Takes one list, sticks the contents of the other list onto the end of it, adds them together. Sure. Now you want to be a little careful when doing this though. So when you take, let's take first list equals 1, 2, and 3, and a second list equals 4, 5, and 6, and then my combined list is first list plus the second list You print the combined list here, right? This is perfectly fine here. But if we go and change my first list, now we'll first list of 1, let's say, equals 0. And how about we change the second one? Second list, we'll assign that one to 0. And print the combined list. No biggie, right? We have a copy. We changed what was in the original list, but we have a copy of it. So we're making a new list here by doing this arithmetic. So some people don't always expect that kind of behavior. Generally, it works pretty well. So you don't want it to be the first and the second still around. It's making a brand new list here. So this doesn't affect the combined list. Right? What can happen though, right, as we're doing this here. So if I say my third list equals the first list here, third list equals the first list, and I were to print my third list. When you say a list equals another list here, this is not a copy here. What we've done is we've said, hey, I have a new variable. It points to this list in memory here. Because a list here is just where does this list live in memory? So the first list is somewhere out in memory. Python has said, hey, Windows, I need a place to store some integers. Great. Okay, here's your memory address. We'll keep that handy. When I say third list equals first list, it doesn't make a copy. It says, okay, third list, you point to that same location that first list points at here. So if I change first list, third list isn't a copy of it. It's pointing at the same location here. So this is known as a shallow copy here, where they're both pointed at the same thing in memory. So when I change the first list here, but does affect third, it's no good here. So what we can do then is we can do a fourth list is equal to my second list sliced. Remember when we did the for loop, we said, hey, a slice will get you a copy of it here. This is a copy here. Kind of like a deep copy. Not exactly, though. You gotta be a little careful. It's not really a deep copy. So if I were to look at my second list and print the fourth list, then, oops, I don't need combined list again. Print the fourth list. Fourth list shouldn't change. It should still be 4, 5, and 6 because we made a copy of it here, which is good. Excuse me. So you got to be a little careful here. You can multiply a list by a number, right? It will take that list times that many iterations of that list. So 1, 2, and 3 times 3 is 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? It's 1, 2, 3, 3 times. Right? Same like you can multiply a string. You'll just get that string repeated. Behaves the same way. You can take slices of it. Right? Works the same way we did with strings. You can change multiple values using slice notation. Now this is kind of funky. I'm not a fan of this, but sure. I can say, hey, I want to take the slice here and change the values of it. This is weird because it's not giving you a copy, it's changing the original. So this one's kind of funky here. But you can do that. Append we looked at. Extend is like the same as plus. Take a list, add another list. Just another way of doing it here. It has a built-in sort, which is really fun. So I can take my list and I can sort it if I wanted. None of those are very interesting. How about the my list? So we can print the mylist.sort here. Will be a sorted version of it. Oops, I'm sorry. Dot sort doesn't return anything. Sorry. So call sort will sort my list, and then I can print my list. We print before sorting and after sorting. Oops, single quote. No, single quote. There we go. Before sorting, sort it. After sorting. Okay, it sorts. So this is a descending order. You can sort characters. Remember, that's based on their Unicode value. Not the most interesting thing, but you can. Now, there's a big difference here. This will modify the list. There's modifies the list. There's also a different way of doing this, which you can print a sorted my list. So sorted doesn't modify the original. Modify the original. It returns a sorted version, a sorted copy. So this one I'll be able to print the sorted version of my list here. And notice it prints out sorted, but then when I print before sorting, it's not sorted. Because this is a sorted copy of the list, not the original. Right? So .sort will change list. Sorted doesn't change my list. Not the most important thing, but that is an important distinction. Right? So if you don't want to mess with the original, make a copy and sort it. Sorted version of it, or you can sort the original. Okay? You can delete items right by index or with the remove method. You can remove a given value. This is weird, this delete notation. I hate this delete notation. And most people don't use it because it's funky here. So it says, hey, delete the thing at index 1. Gross. Remove by value. Great. Lists can do some built-in things, right? The length of lists, you can get the max value out, the minimum value out, the sum out right away. It's got some cool built-in functions. There's no average, though, which is a bummer. Like, you still have to do the sum divided by the length for average. I don't know why there's not a built-in average, but that's okay. Yeah, lists. Split is dealing with strings. So if you take a string, you can split it, and it will turn it into a list of strings based on what character you're splitting on. And by default, it's a space. So his string here, pining for the fjords, right? If you split that, will give you each individual section of the string without the spaces. So every time it finds a space, it breaks it into a new piece here. So there's a lot of things you can do with splitting and then working with those pieces that have been split. If you change what you're splitting on, right, you can split on a given character, like the dash here will split every time it finds a dash instead of every time it finds a space. And then join is like the opposite. So you can take a bunch of items and you can join them on a given delimiter or joining character, and it will put them back together with that thing in between them. So what's kind of nice here, right? We had that two-dimensional list, that 2D list, two-dimensional, or no, we called it a board, right? When I printed board, it was all one line when I just printed it here, right? Somebody said, hey, for row and board, let's print that. Now, people who do a lot of Python are fans of doing things in one line rather than multiple lines. So sure, you could do that. So we would print my board and we'd want to split, we'd say we'd want to print board dot join, no, it's backwards. The delimiter dot join. So we would take a new line character dot join the board. So what that does is it takes each piece in your list, sticks the delimiter in between them. So this now will print out my board. Oh, did it not do it for me? There's print board. Oh, yeah. It only works on strings. So I have to join the string version of the board. I think does that do it for me? Nope, that's too much. Okay, not quite. So let me go back. So we want to join, say, string of the row for row in board. I think that'll do it. Yeah. So this, people will say, is better than this. I generally disagree, but if you do these sorts of, and this is called a list comprehension, you're sort of taking a for loop and sticking the thing you're doing first instead of after. So I'm going to take every row as a string for every row on the board, and I'm going to join them together with the new line character. You'll see it a lot. People who write Python do this all the time. It used to drive me nuts until I've done it more than not. So if it doesn't make a lot of sense, that's okay, but you'll see this all over the place. So it's essentially the for loop, but you're sticking what happens inside the loop at the start. So this is a Lisp comprehension. They're crazy. Keep your lines. This was that two things pointed at the same value here with a list equals a list. So lists are not the same if they are equal, but if you say A equals B, then the is keyword will tell you if they point to the same location in memory. So that's the is operator. It's kind of fun here. So when we said, hey, this A list equals the B list, yes, they're not the same because they have different locations in memory. When you say, hey, A equals B or B equals A, then they are the same because they point to the same location in memory. List arguments. We did lists as arguments. Yep, cool. All right, so that's lists. And then again, tuples are nearly identical to lists, except they're immutable. So you can't do as much with them. So you can still make them all, but then you can't go change them. So, right, you, where's our list? That's sorting. That one's not all that interesting. Tuple assignment. So this is technically a tuple here when we do this x and y equal something. So when we said in our, we closed down already. In our file function, when we returned two values, what Python's technically doing is returning a tuple behind the scenes. So let me go back to that GitHub here. That was lab 6. So when we said, hey, I want to return price and quantity, what was really happening is returning a tuple of price and quantity here, because technically a function can only return one thing. Well, a tuple is one thing, even if it is holding a bunch of other things. A container is still one thing. And then when you say, hey, my price and quantity equal something, it will automatically unpack them for you. So really, this was like a tuple here being assigned a value over here, and we just called them something. So Python has a lot of shortcuts like that, which is really nice for doing those sorts of assignments. It'll also let you swap, which is crazy here. So a lot of times, if you want to swap values for something, we'd say, hey, here's the initial value, let me change the value, and let me put that initial value back somewhere else. Well, Python lets you do it all in one line. But if you don't have the right number here, it will fail, right? You can't say, hey, A and B equals 1, 2, 3. That one's going to crash on us. It's no good. And then we'll get back to tuples, dictionaries here in just a minute. Oh, goodness, it's after 7, folks. I'm sorry. I'm just going to keep talking until someone stops me. So why don't we take a break, and then we'll come back, talk about some dictionaries, and go from there, okay? All right, awesome. Oops, music's muted. We'll come back in about 10 minutes. 7:24. Oops, 10 minutes. Alrighty. Look at that. Song's just ending. I think that's perfect. I'm going to put the volume back up before I forget. All right, so we're going to move on to dictionaries. Now, dictionaries are wildly different animals. Still sort of a collection here. But what happens here, these are mappings here. So there's a key and an associated value. So really this, like my dictionary here, oops, my dictionary, isn't going to look quite right when I go and print it here up at the top. This is fine. It has a 1, 2, 3, 4, 5. Essentially, we've made a list here. Now, what's cool about dictionaries is they only allow unique keys. Because what happens is you have a key and an associated value most of the time here. And so if I were to say, hey, I want a, let's do a new dictionary here, empty, or let's say Gradebook. We'll call it a Gradebook. Equals a dictionary. And I can say Gradebook, key of Eric, Gradebook, yeah, there we go. Gradebook, key of Eric equals, I've got a 100 here. And we'll have a Gradebook key of, we'll put Jeb in here. He has not been doing his homework following along on YouTube, so he's got like a 90% here. So it takes, still with square braces, which is weird, but we'll say assign the key of Eric the value of 100, or associate the value of 100 with the key of Eric. And we'll add Jeb. And then we'll add in Journey as well. Journey wants to learn how to program, but she's not quite ready yet, but that's okay. We'll get there. We'll say she only has like a 75. And I can print the Gradebook. Go back up to the top. So you get a key colon value when you print these out with the default print. So there's a key and an associated value. So keys have to be unique because if this is the assignment way of adding a new value, it's also the way of updating a value. So if I were to say, hey, let's change Eric's score. Oops, I forgot to do this assignment here. And that hurt my score, put me down to a 95. This updates the existing value associated with Eric. Associated value. And then when I print it out, we'll see there's not going to be a duplicate, but it just updates the value here. So dictionaries have a unique set of keys with associated values, which is super cool. So you can remove items from gradebooks as well, or from dictionaries as well. Where is it here? Which one is it? It's not delete. Oh my goodness. It's not remove. So it's that weird notation here. So we delete gradebook key of Journey. We'll delete an item. So it deletes the entry. Really, you kind of want to think of it as entries with a key and an associated value. But we'll just remove that one completely from the dictionary. That notation's super weird though, but that's okay. So you can add or update with the same notation. Doesn't work like that with lists, right? With lists, you have to either append it to the end or update a specific index that has to exist. If I were to try and take my list and say, hey, index 10 equals something here, it's not going to work. Because, hey, the index assignment is out of range. There is nothing at index 10. You can't do that here. Right? So this only works with existing indexes. Existing indexes. With a dictionary, it just works here. Now, because it's a key and associated value, there is no order. Guaranteed in dictionaries. Now, for our purposes, we're going to get them out in the order we put them in for quite a while, but eventually it's going to mix them up here. So if you want to loop through a dictionary, you can say for key in my gradebook, you can print the key, oops, I need a formatted string here. Key and value or associated value is going to be my gradebook key of the key here, associated value here. So when you loop through, this will give you every loops through every key. not every value. So you'll get out the key here, and then you can use the key to get the associated value back out. So to read a value, it's the same notation as well. So if you wanted to print Eric's score, to print Eric's score is, let me just do a formatted string here. So same for adding, same for updating, same for getting the value back out. So a little crazy here with dictionaries, how use the same notation every time. We can say, hey, here's the key, here's the associated value, here's the key, here's the associated value. We get the back out, so when we loop through Gradebook. Now, eventually this order will get mixed up here. Again, for our purposes, we're not going to hit enough. It has to get large enough for this to happen. There's a whole reason why behind the scenes, but it's going to do that for us. So if you want just the values out, you can get just the values. You can say for value in gradebook.values, we could print out just the value. Now, just knowing the value is probably not very useful here, though, right? If we don't know what it's associated with. So sure, I know what the values are, but that's fine. If I wanted to see if something is in the gradebook here, we'll say, hey, if 100 is in my gradebook, or no, I'm sorry, that'd be like 95, right? We could print someone has a 95, else print no one has a 95. Now, we're going to get out no one has a 95 because the in word here only works with keys. So by default, we're only looking for keys with the in operator. So if you look for a particular value, it's not going to do it. But if you say, hey, gradebook.values, then we can do it here. Right? If you want to find, does someone have a particular value? Sure, we can do that. Right? Somebody has a 95 because we looked at the values particularly. If you want to look at if someone is in your gradebook here, we can say, hey, if Eric is in the gradebook, that is what Eric is in the class. In the class. Otherwise, not in the class. And turns out Eric is not in the class because lowercase e Eric is not the same as uppercase e Eric. Right? Remember, case matters in strings. So a lowercase e Eric is not the same as an uppercase e Eric. So what that means, though, is I could take Gradebook and put an Eric here, and we'll get multiple Erics now when I print out my Gradebook. Right? We'll have uppercase e Eric and lowercase e Eric. And I'm going to pretend to be lowercase e Eric and say they just made a typo on my birth certificate. Right? I should get the 100, not the 95%. Although they're both A's, so it's probably not worth a lot of hassle there, right? Because A plus is not a real mark. So keys are case sensitive. Sensitive. There we go. Why is it not like case sensitive? Word is normally spelled with a hyphen? Really? That's how you do case sensitive? Okay, sure. Now, just like a list can have multiple values in it, a list can have a list of lists. A dictionary can have other collections as associated values. Now, you can't make a list be the key here because bad stuff happens. But if I wanted to take my gradebook here, and say, let's do gradebook key of, I can't say key of 1, 2, 3 equals 4, 5, 6. Lists aren't going to work here, right? You get this funny looking error, unhashable type. Means a lot of things. Later on, if you take a data structures course, you'll learn what hashing is all about. Don't care too much right now. We're not too concerned. But you need to be able to find a particular value for an item every time. And because lists are mutable, they don't hash very well, and bad stuff happens. But what's cool is you can make a tuple be a key if you want, and it's perfectly fine with that. So my tuple of 1, 2, 3 is the key has an associated value of 4, 5, 6. I don't recommend this, but you can, right? So tuples, but not lists, be as keys, or hey, by the way, you can have a list as an associated value. So maybe a more interesting gradebook then might have the student's name as the key, and then another dictionary of, hey, lab 1 and a score, lab 2 and a score, lab 3 and a score, lab 4 and a score, that sort of thing. So we could build all that out if we wanted here to start populating this my dictionary here. So let me get started on this for fun here. This will be kind of the start of lab 7. I want to get it started here. We're not going to do a lot of it here. So if I were to have my gradebook as a dictionary, and then I can go and add students to the gradebook, right? So let's define how about add student, given a gradebook. Let's just pass this around a lot. Maybe we'll do it that way here. So if I give you the gradebook, I can go add a student to it. No, I don't want that here. So maybe we'll get their name as an input, or the student name. And then we can check, hey, if the name is in the gradebook, we can print, I don't know, name is already in the gradebook. Otherwise, then we can go and add them. We'll say, hey, here's my gradebook, key of name. We'll assign an empty dictionary for their associated value. We've added student with an empty record here, nothing else in it. Okay, so I'll have my gradebook, and then I can add student given the gradebook, and then we can print out the gradebook here. We should be able to see, hey, we added a new student here. I'm sorry, I want to do this more than once. Let's do it. Let's do it like 3 times here for fun. So we'll add 3 students. So if I add Eric, I add Eric again, it tells me, nope, I'm already in the gradebook. But again, if I add lowercase e Eric, that's perfectly fine because it's different than uppercase Eric. So if you're dealing with that sort of thing, we probably want to lowercase all the input here to make sure that all of our keys being entered will always be lowercase, because who knows what the user types in. I don't know why, but some people will send me messages in all caps, like with an email, and I feel like they're yelling at me because that's, all caps is the internet equivalent of yelling, and you have to explain to people that please don't send me messages in all caps. Like it's very frustrating. So sure. So if we lowercase everything, then we'll make sure that we get unique strings every time. Okay. Then if we wanted, we could say, hey, let's add a function for add assignment here, given the gradebook. So we'll say, let's get the assignment name. Assignment name is an input of the assignment name. And then now I want to say for key, or how about student in the gradebook, let's take the gradebook key of the student, key of the assignment name, and add in, I don't know, a 0 for now, because we don't know what their score is. We'll just add in the assignment here as a 0 for now. So we can add some students, and then how about we add an assignment here? Let's add 2 students maybe. We'll add an assignment for the gradebook. So we'll add Eric, we'll add Jeb, and then the assignment name, how about we do, this is lab 1. So see, Eric has an associated value of a dictionary that has lab 1, and Jeb has an associated value of a dictionary that has lab 1. Great, it's fine. Maybe we want to actually score it at this point in time. So how about we do that? So how about we say the score is an int of an input, enter the score for student. There we go. And then we can assign the value of score here. That's probably a little nicer, right, than starting with zeros. So we add Eric, we add Jeb. Okay, enter the assignment name. This is lab 1. Enter the score for Eric. Eric got 100%. Jeb got 90. And now we see we've got associated values here. And we can do it again. But we might want to check to make sure we already have this assignment, or maybe lowercase this one too, dot lower. So if you add in the same assignment, it might be okay. We're just going to overwrite it here at this point, because remember, it's an add or update. It's probably okay. So, and then how about we have a define, I don't know, print average for the gradebook. So we'll say for student in the gradebook, we want a total, right? Their total is going to be the sum of the gradebook key of student will be their associated dictionary, and we want the values there. right? Or you can sum up a list. So the list of values, or really it's a tuple of values. We can sum up the list there, divided by the length here. And then we can print out student, what average score is the, that should be average, right? Not total. All right, so let me add 2 assignments here. And then we'll print average given the gradebook. Okay, so we'll add Eric, we'll add Jeb, we'll have lab 1, got 100 and 90, and we'll add lab 2, maybe 95 and 80. So Eric's average score was 97.5, right? The average of 195, sure. Jeb's was 85, right? Average of 90 and 80. Seems to be working so far. So a dictionary of dictionaries, right? A two-dimensional dictionary sort of can conceptually make sense. It's still kind of tricky, and there's other ways to do this once we start talking about Python classes, but we haven't got there yet, or Python objects. But dictionaries are really fun in that you can kind of build this out and say, okay, here's the key, here's an associated value. Okay, well, that associated value is another dictionary with its own set of keys and values for these sorts of things here. So we've got averages. Now, the problem here is if I were to go add a new student after I have an assignment here, what are they going to get? So if I go add a student here, given the gradebook, right? So we'll have Eric, we'll have Jeb, we'll have lab 1, 100, 100, lab 2, 100, and 100, and then another student's name. If I were to go and add Journey to the class late, well, she doesn't have any assignments now. It's empty. Well, that's not great, because if I want to add her later, I probably would need to go get all of the assignments out first. Right? If I'm going to add somebody, I need to go find the list of assignments somewhere and go and get the score for all of them. Well, that's kind of annoying, right? But we can do that. So if their name is in the gradebook, they're already there. Otherwise, we'll go and add them, and then we need to go and get all of the assignments, right? So I'm going to say for assignment in, and that's going to be my gradebook key of what? Well, I need some value. I don't know what value it is, so I need like an existing somebody here, right? So I have to go find someone's key, right? Or I can say, hey, gradebook keys. So keys will give you the list of keys out, right? We've been able to loop through a gradebook before, but I can get the keys out instead of just the values out and say, hey, give me the first one here. 0. I guess maybe we want to check if the length of gradebook does not equal 1. Right? If they're the very first one, the length will be 1. If they're the very first student. If they're not the very first student, let's go make sure we have all of their assignments. Right, so go get the list of keys, go take the first item there, so the first student that we added here, sure, we'll go add them in here, and that will get me their dictionary, which is a key of the assignment name here. And then we'll take gradebook key of name, and we're going to add in another key of the assignment. Well, we need to get their score, right? So enter the score for their name. Enter the score for name here, right? This is name for assignment. We'll figure out their score, and we'll add in that value here. And this is where it starts to get kind of crazy here, right? When we have this dictionary of dictionaries, because we're looping through, trying to find the key out, trying to get the other student's name out here, so that I can go copy all of their assignments over, get all those scores, but it should work. Let's try it here. So if we have Eric, we have Jeb, oops. Oh, that's right. Dictionary keys is not subscriptable. So it looks like it's a tuple, but it's not actually, which is crazy. So you can say, hey, I want a list of this thing. Then it'll turn it into a list I can take the first thing of. It's a little messy, but I think it'll be okay. So, all right, so we have Eric, we have Jeb, we have lab 1, 100, 100, lab 2, 100, 100, and we'll add journey. All right, and then journey score for lab 1, 100, journey score for lab 2, 100. So it adds her in by copying all the assignments from someone else's dictionary. Still really messy, but sort of works here, right? Kind of works here. It's a lot of work here. Does that make a little bit of sense, working with the dictionary of dictionaries? Because if we add them in the wrong order, it's going to be really confusing here. So when we add assignment, it adds it for every student. But if you add a student, we have to go add all those assignments back for them. And then we should be able to print out the totals, or print average, and it should work out pretty well. I think if we were to print average, we already did it. That's okay. All right, so that was our dictionary of dictionaries. Excuse me. Now, this doesn't really work with the way that points work, though, in our system. Like, just because you got 100 on the lab doesn't mean that your average will be a 95 if you got a 90 on the midterm. Right? The labs aren't worth as much as the midterm. Or each individual lab, I should say, isn't worth as much as the midterm. So if we really wanted to do this, we would have to have a category, a dictionary of categories that have the category name and the category value, and then the list of assignments inside of that. And now we really have too many things going inside of dictionaries, going inside of dictionaries, going inside of dictionaries. And we've gone a little too far here into that like third dimension, and life will be rough, right? A second dimension is hard enough here, but still relatively straightforward, right? You have the person and you have their list of assignments and scores. That's the second dimension. Person, their list of assignments and scores is your second dimension. If you also have to track categories and then points for the categories and overall weight of the category, it gets kind of messy here. The other option we could do is we could store the assignment name, the assignment total points, and the assignment earned points. Right? We could do that. So we could have lab 1 total points, we could have lab 1 earned points. So I could know, okay, they got 10 out of 10 points for the lab, and for the midterm, they got 20 out of 20 points here. And then I can total up all of your points and figure out your score that way. Right? But to do that, then we need different values. So it's not just a straight assignment here, right? It would be the assignment total points and then the assignment earned points. So we could change this when we add an assignment. We could say the assignment total points is an int of an input. How many points is the assignment worth? Right? And we can add that in as a value. Again, it's probably going a little too far here with our dictionary, though, right? Where we've got too many different things happening. This is probably straightforward enough here. You feel okay? All right. So I was going to do this for the lab, but forget that. That's going to be too crazy here. So let's build out that same idea of our shopping program, but instead of files, we'll do it all in a dictionary. We do that. We can have a key of the item. Here, so let me build out that. Let me do another GitHub classroom here. We'll talk about the lab assignment for some practice. That'll be lab 7, CIS 2131, 2022, lab 7. On template late. There we go. All right, so copy that. I don't think I made any changes. So this will be our lab 7 lists and dictionaries. 10 points for labs. So next week is the 25th for class starts. Submit the URL for repository, please. There we go. And you're going to just turn in text. So create the shopping program again, but with a dictionary and not files. So have a dictionary of the item name as the key and associated values of a dictionary with price and quantity. Right? So same idea with the student gradebook. The key was the student name. The associated value was a dictionary of assignments and scores. We'll have an associated dictionary with the price and the quantity. So we can say, hey, price equals something and quantity equals something. So we can find what the price and the quantity are for the particular item here. Okay, so manage, we'll go and add them. Right, we can say, is this key in the dictionary? Update can just update the value. Right, if it doesn't exist, it's not in the dictionary. If it does exist, great. To remove something, it's that funny del keyword. Right, we can delete. Oh, that's in my other one here. Sorry. You can use the delete. And then when we go and shop the items, we need to update the associated quantity. Right, so get the dictionary key of the item, update the associated quantity with however many we purchased. Okay, that make sense? So similar to what we did with the gradebook example here. Let me go and commit these here. So this is dictionaries. So we got to work on that one, and then we'll talk about our last project, our last individual project, okay? Why is this one locked? Oh, that's fine. Project 4. Doing one more assignment here. 31, summer 2022, project 4. Python template. This is project 4. So this will be due in 2 weeks then before class starts. And I kind of look at, I think the last one was 14 points. This will probably be about 16 points here, right? Because they keep going up in points here because they're not going to forget anything. Submit the URL to your project and a self-assessment using the rubric. Rubric assessment. So project, and we'll add in the rubric here in a minute. All right. So using our lists and dictionaries and files, we're gonna have a little bit of fun with this one here. So we're going to see if we can't build out a little bit of a registration system. Doesn't need to be super complex, but it should be, handle a couple things here. So we're going to create a registration system where user can create a class by name, like CIS 2131 Python programming, and a list of students registered. So we can make as many classes as we want. So allow the user create many classes as they want. Okay. And then, so it's for like creating classes and include a maximum class size and don't allow more students than that to register. Right, so this class can have 27 students or 30 students in it. After that, we can't register anymore. Right, so we're going to have information about the class here. And then we also want to then have the list of students who've registered. So when a student search for the class, or a class, add their name to the roster. We need some way of storing a roster, right? Which is another list of students, right, associated with the class here. right? So we need some way to store that. Add the name to the roster if there is room, right? Otherwise, tell them there's not room here, that sort of thing. And then we're going to additionally then have a way to look at a single student's schedule. Add a method for printing a student's list of classes. So for a given student name, we need to go and see which classes they're registered for. Right? So we're keeping the classes here with the list of students, and then we're going to keep or have a way to find, okay, find all the classes this student is in as well. Okay, so you'll have to look at all the class rosters. Probably the easiest way to go about that. So go and look at all the class rosters, see which classes they're registered for, and go that way. Allow students to, what is it, unregister, deregister, drop, unenroll. I don't know what the right word is. Unenroll from a class, move them from the roster. And then don't forget to update the class file. Right, so our classes should be saved as files here with class information, student rosters, and then students can go and register for classes, this sort of thing. So we have really like the class management where we can add a class, manage classes. So we need two modes really. I don't know what, administration mode and student mode. In administration mode, allow creating, updating, and deleting classes. Student mode, allow enrolling, printing schedules, and unenrolling from classes. That makes sense what we're going after here? Okay. Updating, deleting classes, and I don't know, printing class rosters. Right? You should be able to see who's in it. So the update here is just update what's the maximum allowed. Updating, printing, deleting, and printing rosters. Okay, then students can log in. Hey, what's your name? Okay, do you want to enroll in a class? Do you want to see your schedule? Do you want to unenroll from a class? That sort of thing. Okay. Not.
Schedule just means which classes.
Yeah, just what classes you're enrolled in. Printing list classes enrolled in. Yeah. No need to like check and see what date and time a class is offered. That's beyond this. All right. So then that's 1, 2, 3, 4, 5. Okay, perfect. So this will be a new project 4 rubric. So this is if it's missing or if it's complete. So this is 6 points for admin mode, create, update, delete, and then student mode, register, unenroll, enroll, unenroll, print classes, and this was printing schedule, right? Print class roster. Okay, so this will be custom points here. There we go. So 8 points, that's like 2 points each. And then 6 points for the student mode, 2 points each. Save in files. Because if you're not saving all this data, trying to like re-enter it every time is going to be really obnoxious. You need a way to read and write the files of these class files. Okay. And then this overall score. Get rid of that. Overall score. Oh no, I'm sorry. It's supposed to be 16 total, right? So we need 8 points each. That's right. So I can't do math. Yeah, that's 8, and that's enroll, print list of classes. There's no update there, so that's only 6 really there, right? 6. Oh my goodness. Click in the right box, please. And save in files, 4 points. There we go. We'll do 10 here. So 4 points for doing it in files. 2 points for doing the actual update. So if it doesn't save to files, that's just 4 points here. That make sense? All right, awesome. So that's what we've got for the next project. Kind of, again, trying to put together a lot of the things we've been working on here. This is our enrollment system, our class management system. Sure. So using lists and dictionaries with associated values, which might be lists, right? Your list of students could be an associated value somewhere in there, that sort of thing. Right? It's a lot. It's a bunch of new things, a way of dealing with multiple pieces of information all at once. So got to get some practice in. Work with some dictionaries, work with some lists, access them. The slicing part is interesting and all, but how often do you really know, like, hey, I need the 3rd through the 5th item in this list? Not all that often here. So mostly it's, here, I have a bunch of things. Let me loop through, do something for each one of them most of the time. Where slicing was much more interesting for strings. So, all right. Awesome. So we got time to work on the lab here, and the project. If you want to get started on that, and then next week, again, we'll pick it up. A couple specialty topics. Looking at web services is super fun. Most of the things we do when we talk to web services will give us back lists of information. Occasionally, you'll find something that will just tell you like one piece of information, but a lot of times it's a list or some kind of collection or a dictionary here. One of the most common ways of sending data across the internet happens to be this JSON format, which is JavaScript object notation. And Python says, oh, that looks like a dictionary. And you just interact with it as a dictionary, and it's super handy and really cool and easy. So we'll use a lot of that when we deal with network programs and web services, turning stuff into dictionaries and interacting with it there. That should be a lot of fun. Regex, we're just going to look at how it all works. It's not worth memorizing, and Regex is really hard to do right and do well, but it's a cool thing you can do with Python, or most any language you can do, and we can go from there. So we'll have some time next week as well, but we'll look at some fun examples, see if we can't build out a little stock program, looking at the Yahoo Finance API. And then objects. So our final project will use Python objects. So we don't need to store anything in a dictionary or visualize or plot anything. Those are just extra topics we're going to look at. But the final project will use objects to do a little simulation here. That should be a lot of fun. Okay. All right. If you folks online have anything, hit me up, send me an email, or find me on Discord, send me a text. I'm happy to hop on and help you out. If not, we'll hang out in class and start working on some of these labs. All right. Thanks, everybody.